Hi class, we need to take a look at problem E. Now, problem E is a little bit different than the inequalities that we did earlier. And this is because of the following. Notice that the actual statement has an absolute value. And absolute value means distance away from zero. So technically, if we were to draw this, this is zero. And notice that it's talking about an absolute value greater than 3. So technically, this is 1, 2, and 3. And if we're talking about a distance greater than 3, well, you could be referring to every value. Let me make this a little bit darker. So we're talking about every value to the right of the distance of 3. In this case, we're saying that that's 3. But notice that the current graph that we have only actually has these distances. And as we're referring to distance, well, if you look at the negatives 1, 2, and 3, we also have to include the values on the left because in terms of distances, they're also greater than 3. So in this case, we're looking at this to be our solution. So let me fix that arrow. And in this case, that would be our graph. When we're talking about an interval notation, notice that any distance that is greater than 3, it's going to be, well, from negative infinity up to negative 3. So in this case, negative infinity to negative 3. And then in order to use symbols to describe that there is a gap, we typically use the symbol union. Union means there is a gap, and then it continues from 3 towards the positive infinity. So technically, with the interval notation, we're saying there is a gap between these two, and technically you're reading it as a single interval. You're saying all the numbers from negative infinity up to negative 3. There's a gap in between, then from 3 to positive infinity. The setability notation, it's going to use the set of x's such that x is less than negative 3 and the word or, and x is greater than 3 and x is a real number. In terms of the symbols here, the union represents an or statement. So whenever you see an or statement, that means the addition of these two. And that's it for this particular one that has distances greater than 3. Let's talk about F, which is similar to E, but in this case, we're looking at distances that are less than or equal to 4. So we're talking about, in this case, this is 0, 1, 2, 3, 4, and then 1, 2, 3, 4. In terms of the actual number line, it's going to look similar, except that on this one, it's saying less than. So technically, this would be less than, the edges will be greater. So for this one, less than means in between. So technically we're looking at, and I'm going to use the bracket in between those two. All these distances are going to be less than or equal to 4. So from here to 4 and from here to negative 4, if you were to measure, there's a distance of 4. Therefore, any value in between, including 4, it's going to be less than or equal to 4 units. Your interval notation, it's going to have bracket, negative 4, comma, 4. Notice that we're not including, the infinities because it has an upper bound of 4 and negative 4. Setability notation, well, we could do that one in a similar manner as the previous one. In this case, this will be the set of x's such that and x is less than or equal to 4 and greater than or equal to -4. And then x is a real number. That's it for F. So F represents distances less than 4, less than or equal to 4. And E represents distances greater than 3. That's it for these two. Let's move on to G. Now, G is a little bit of a tricky one because of the following. Technically, this is 0. And the statement reads here, a distance greater than -3, which technically can be translated to a distance greater than or equal to 0. That's the actual inequality if we were to simplify it. And that's because any distance, the minimum that it can be is 0. So all distances are going to be greater than or equal to a negative value, which means greater than or equal to 0. So in this case, we would typically put a dot on 0. Let me make this thicker. And then we're including all the values to the positive infinity and all the values to the negative infinity. So all numbers on the number line, because all distances are greater than 0, in terms of the interval notation, from -infinity to positive infinity, or any number on the number line. So for the Setability notation, x is such that x is a real number. As I mentioned earlier, this one's a little bit tricky because any distance, it's always going to be greater than a negative value, or in this case, a negative number. The minimum a distance can be is 0. Now, G represents all real numbers since all distances are greater than or equal to 0, and it should not be confused with H. H reads any distance less than a negative. In this case, -3. The minimum that you could have in terms of a distance is 0. You could not have a distance being negative. So in this case, your solution, it's going to be the actual, well, no value is going to satisfy this one. So if they mention an interval, we would say none. If we're talking about a set builder notation, this will just be the empty set. So I'll just write it as a 0 where the line across. And basically, this is one of those problems with no solution. And that is because there is no distance that can be less than a negative value. Now, if they're asking for a graph, we would basically still write the number line, put 0, but no shaded values. And then they're asking for an interval, we would typically put none or no interval in this answer. Set builder notation, the empty set, which is typically the squiggly brackets with no values in it, or a 0 with a dash, or simply write the empty set. So in this case, H is one of those problems that doesn't have a solution. G, it's the complement, it's all real numbers. So careful on these two. They're a little bit tricky, especially because of the nature that we're talking about absolute values. So these are special types of distances. Any distance can be greater than 0 or a negative value, but they cannot be less. That's it for these problems. I'll put the rest of them on a different video.